up the experiment, it was based on the idea that the gravitational waves would come in such a way that they would slightly deflect the mirror, I mean, ever so minutely. And that would, it was a large, what do you call it? It'll come to me. It's the same thing as the Michelson-Morley experiment. It just dropped my mind. It might come to me anyway. Laser something. But you can't compress or displace space, and that's what the interferometer, right? You can't compress space. You can't displace space. There's nothing to displace. There's nothing to compress, which is another problem with this singularity, because if you have space, like a singularity opens up, creates its own space, matter, gravity, and everything. You can't compress space. So you can't compress space into a singularity. There's nothing to compress. Right. So that's another problem with the singularity, and it doesn't need the inflation theory or any of that other stuff, right? Very simple. So you can't compress it. Cosmic seed bursts forth, and that's what I'm saying. It comes into the universe, the space is already there, and it sort of like a flower just bursts out. People have said, in fact, I read a paper, a series of papers about the sun, or stars in general, and it was, I mean, I thought it was really good, but it says, well, space isn't like a fireworks, bursting in, or a bomb or something like that, and I'm saying that's exactly what it is. I wrote back, or I emailed the professor again. I said I really enjoyed the, the series that he had, or a paper on stars, but I didn't say anything about the space because I think you'd just kind of freak out. So I just left it at that. But yeah, you can't. Yeah, see, yeah. So the seed sort of bursts forth, right? Like a seed coming from like a sunflower seed just coming forth and coming up into it, right? It doesn't create its own space as it goes. Space is already there. All right. Anything else important here? No frame. Oh, no frame dragging. If there's no space-time, there's no frame dragging, right? I've read the papers, and there's nothing there either. I mean, this idea of the general theory and space-time, and it's. Yeah, web space. This idea that objects are sort of caught in a spider's web of space and moving with space. No, they're all independent, right? Time, space, and objects are all independent, although they can come together by gravity. Right? What else? I was going to say something else. Yeah, no, not that. No frame dragging. Lost my train of thought. Web, space, time. Yeah. Okay. Let me see what I got here. Yeah. Just some notes I read. Right. So going back to the water, it's right. No mass, no refraction. Right. That's basically what I pointed out. No mass, no refraction, and no dispersion. Right. If a photon does not have mass, you wouldn't get any of that. Yes, the birth of Venus, string theory 10, collision. Okay, collisions happen all the time, pre-existent space. Yeah, we talked about much of that, right? We talked about all that, everything. It's, like I said, it's a little rough, but at least I'm trying to get the ideas across, that it's not what they're saying now, that you have a seed or whatever it is, and all space, all matter, all time, all everything just bursts forth into what? No one has a clue. They'll say, well, nothingness. That's space. Well, no, that's not space. And what is it? Oh, it's nothingness. It's a round argument. You get nowhere from that. All right, I think I've got everything for that. Let's see what else I got. Okay. Botticelli collision. Okay, let me take this down. Let me just check to make sure it's there. Okay. Point number 2. The shape of the universe. Well, people have come up with ideas of the shape of the universe. On the next whiteboard, I'll sort of show some of that. No one knows, but you start with the simple, right? What you don't do is come up with a 10-dimensional pseudo-space, or 11-dimensional, or a 26-dimensional. The numbers have absolutely zero meaning whatsoever. I mean, just nothing. Like my little chickens do, right? That's where I get all my great idea, all the chickens. Anyway, yeah. So start with the simple, and the simplest model is what? if the universe did in fact come with sort of the Big Bang, and I'm right about, space has to be pre-existing, then space was there. Why? Why not? I guess. I don't know. It's very hard to contemplate that. Space is just, that's it. And there's matter within space. So they perhaps go together. What is the Chinese symbol? I forget what it is. There's sort of matter. There's matter within space, and there's space with matter, right? So, sorry. Space pre-existing, then boundless, right? In other words, if you have space, like in Newton's version of space, what bounds are there? There aren't any bounds. So these things might just be going off, our universe going off, into something, and maybe, 1,000 light years or 700 billion thousand light years away, there's another gob of mass somewhere, and something will collide together and create another view. And we don't know, but it's I'm seeing it as boundless, matter expanding into the void. Yeah, I mean you can't. It's not like again. It's like I don't know what you'd call it. A little grain of sand or a little cosmic particle, if even that, and somehow that creates the entire universe. That is extremely doubtful. It doesn't. I mean, it just doesn't make common sense. I mean, and there is common sense in science. There is common sense in science. It might be Occam's razor, but there is common sense to be used in science. So, okay. Probably flat. Well, there's sort of flat, hyperbolic, and a spherical, and I think it's just flat. So a lot of this, it just sort of predates when about the time of Einstein and Minkowski, started talking about space-time, and Einstein brought in gravity into the special theory and sort of worked it out to the field equations and whatnot. But take your simplest one, right? I mean, that's Occam's razor, right? Take your simplest form. What's the simplest form? Flat space. So I think that's sort of goes what my thinking is. Right. So I think in the models, I mean, I've read about the models of gravitation and whatnot, and they're all, the ones that are based on Einstein. And yeah, I don't see any of those being true. If you look at, like everybody learns what? The Schwarzschild solution, right, for the general theory, right? But it's so restricted, it has nothing to do with reality. And the same with the Kerr solution. It has, a lot of restrictions, has nothing to do with reality. It's sort of a partial, model. So I don't agree with any of that. Space is not uniquely paired with matter. In other words, the moon, or our solar system is anchored, or caught in the web of space-time and kind of moving along with it, and this is the only place it can be. That's not really happening. Like I said, time doesn't exist, and matter, there is gravity out there, and I try to explain that on my previous video. Which is a simple gravitational model of the universe. You can go look at it. I'm going to bring it up, what I said before about what I found when I was reading. Okay, it's not, so you don't have this unique pairing between the solar system and this is where it is and it's expanding out and it's caught up in this web of, it doesn't. That's not it. It is what it looks like. I think in many ways we have to go back to a simpler model and try building it up from there again, because following the general theory it's not going to lead to anywhere. It has little or nothing to do with reality. I mean, there are certain situations that come up, like what I talked about before, per Mercury, the precession of the perihelion of Mercury, right? And that somehow had to be corrected, but maybe it's not. The perihelion. I mean, what we see it is wrong. Maybe we don't understand enough of the physics of the system between a sun so huge and Mercury, and we think it behaves in just the same way that everything else does, and maybe not. Maybe there's something else going on there that it could actually be seen as a simpler solution, right? Just because we think this has this much mass in it, it's sort of based on other items going around. Gravitational attractions and moving and stuff like that, but it doesn't mean that we're right just because we sort of try to peg this. We could be off by enough of a mark that Newton's theory wouldn't hold. I don't know. Onward we go. There must be, I say this, and I'm going to bring it up now, but right, you're looking at the different types of universes. What I said in my first whiteboard, nobody really knows. I mean, we're trying to understand how this could happen. I look at the most simple explanation possible, which is space is existing, matter is there, but you say, well, you can't explain that. You're right, I can't explain it, but neither can anyone else. And just saying, oh, well, it's a singularity and it's infinite mass and infinite heat and has no geographical space, take out no space to it, that doesn't make sense either. I mean, where did that come from? Where is that? So, with the collision model, if you wanted to go that way, I don't, or yeah, if you wanted to go with the collision model, I lost my train of thought.